All right, this is the 2018 BC problem for Polar, which was number 5 on that exam. So they gave us the graph of two polar curves, r equals 4. So r equals 4 is going to be, I'm going to call it R1, just so I don't have to write everything. That's going to be this circle right here. And then the other one was the cardioid. So R2 is going to be 3 plus 2 cosine theta, which is this piece right here. And they tell us they intersect at pi over 3 and 5 pi over 3. Now, AP often gives us the graphs and the intersection points because they're checking the calculus, not with the pre-calculus, but let's go ahead and do that to make sure we know how. If we want to know where those two curves intersect, you would set them equal to each other. So cosine theta is equal to 1/2, and that happens at pi over 3 and in quadrants 1 and 4, so pi over 3 and 5 pi over 3. So that works out. A, let R be the shaded region inside the graph of r equals 4 and outside the graph of the cardioid. Find an expression for the integral involving r. Okay, so remember, area for polar is different. It's 1/2 the integral of r squared d theta. We're not concerned anywhere with a part over here with the curve, so we're not going to start our integral till pi over 3. So I'm going to go from pi over 3, and I'm going to use symmetry. I'm going to stop here at pi. And we're going to cut from the biggest curve and then subtract off the smaller radius. So my bigger curve would be R1 squared, and then we're going to subtract off R2 squared. There was a 1/2 in the formula, but we used symmetry, so we multiply it by 2. We could have also written this as 1/2 the integral from pi over 3 to 5 pi over 3, and then R1 squared minus R2 squared. So either way works. Remember, with polar integrals, there's a lot of ways to do each of the problems. So this first part was worth 3 points. You got 1 point for getting your constant right and whatever's out in front. So your constant out in front and your limits of integration, and then you get 2 points for getting both of those right. So you'll get 1 point for the subtraction and 1 point for remembering to square them. Part B. The slope of the line of the graph, tangent to the graph of R, find the slope of the graph at, okay, so I want to find the slope of R equals 3 plus 2 cosine theta at theta equals pi over 2. Now this is a non-calculator problem, so we're going to have to go through and do the entire thing, and that's why they didn't have us integrate the part A, because it would have been a long process to do all that. So we want to find the slope. So we want to find dy dx. Well, currently our equation is in r's and thetas. The only thing I can take right now is dr d theta. I don't even have an x and a y. So I'm going to first express my polar equation in terms of Cartesian. So x is the same thing as r cosine theta. So for our problem, it's going to be 3 plus 2 cosine theta times cosine theta. I'm going to go ahead and multiply that out. I'm also find an equation for y. Y is r sine theta. So for our problem, 3 plus 2 cosine theta sine theta. And again, I'm just going to multiply that out. All right, so I want dy dx. I was able to express x in terms of theta and y in terms of theta, which means I can find both dy d theta and dx d theta. right, so let's go ahead and take our derivatives. So dx d theta, derivative cosine is minus sine. Here we have a power rule, then a chain rule. So 4 cosine theta times a negative sine theta. And I'm going to go ahead and evaluate this one at pi over 2, because that's so plugging it at pi over 2. So at pi over 2, sine is 1, cosine is 0. So this piece is gone. So dx d theta is negative 3. Same thing over here. dy d theta, the derivative sine is cosine. Then we have a product rule. So the derivative cosine is minus sine, copy down the other one. Derivative sine is cosine, copy down the other one. And again, we're going to be evaluating this at pi over 2. This is 0. This is 0. So this is negative 2. So since we know dy dx is equal to dy d theta over dx d theta, you're going to have 2/3. This is worth 3 points. 1 for expressing it at x and finding dx, 1 for finding y dy, and then 1 for writing the correct ratio. Part C. A particle moves along a portion of the graph, the cardioid, between 0 and pi halves. The particle moves in such a way that the distance between the particle and the origin increases at a constant rate. Okay, the distance between the particle and the origin. Well, the distance between the particle and the origin is r. So they're telling me the distance between the particle and the origin increases. So dr d theta is increasing by 3 units per second. Find the rate of change the angle makes with respect to time at the instant the position of the particle is at pi over 3. So find the rate at which theta changes with respect to time. So we want to find d theta dt. So let's see, I have r, and we know dr d theta, and then d theta dt. So if we want to find dr dt, that's going to be equal to dr d theta times d theta dt. So let's see. I know what dr d theta is. Dr d theta would be, sorry, I'm running out of room. So dr d theta is just the derivative of the cardioid. So minus 2 sine theta. And we want to know at pi over 3, so I'm going to go ahead and plug in pi over 3, which is root 3 over 2, so negative root 3. So I know dr d theta, this right here is negative root 3. And hold on, I made a mistake. This should be the dr dt because it said the rate with respect to time. So we also know dr dt is equal to 3. So I know this is equal to 3. And it wants us to find d theta dt. So d theta dt is just going to be 3 divided by negative root 3. And that would be in radians per second. Make sure you use the units. Radians per second. That is also worth 3 points. 1 for writing a relationship between 3 derivatives, 1 for finding d theta dt, and 1 for finding dr d theta.